Okay, welcome everybody to our virtual meetup, our monthly virtual meetup. So it's August. So it's our August meetup, which is awesome. And we have our very favorite guest, which is weird to call you a guest because you really are Salt. So Tom Hatch is here with us to tell us all about pop. So I just want to make jokes now about putting salt on your popcorn because that's what I think about every time. But I think I've made that joke every time we've talked about pop. So I will ease up. And we have some cool members of the community here. We're glad you guys are all here. We're going to just turn this right over to Tom and let him dive in to talk about pop. There's so many things to dive into. So I'm really interested to hear what angle we're going to hit on today.
Yeah, so I've got a pop intro prepared. One of the things that I'm kind of excited about with this presentation is that I haven't given this view on pop in a while. So we are 10 months into the VMware acquisition, and it's been really fascinating how we've worked really hard to make sure that Salt is positively affected, and I believe it has been by the acquisition. But it's also been really interesting how many people, especially internal to VMware, have been really fascinated by what we have with POP and plugin-oriented programming. I've gotten a surprising amount of really positive and exciting feedback inside VMware. And at the same time, I need to remind myself that a programming paradigm, a programming style is something that takes a lot longer to get traction. And we've seen more and more usage of POP, but more excitingly, as we've had some internal projects using POP, we've seen people do some really impressive things with the paradigm. And so I'm going to dive in and give an overview of the philosophy of POP and do a little bit of a demo of how to build a POP project from scratch, and we'll go from there. So POP stands for Plugin-Oriented Programming. Everyone, of course, I say everyone, software developers are, of course, familiar with programming paradigms as a construct. Programming paradigms, the most popular, I should say, why the most widely used programming paradigm is called Object-Oriented Programming, and a very venerable and widely used paradigm. And there are some reasons why I think that introducing a new programming paradigm today can have certain benefits. And there are things that I feel that you can do with plugin-oriented programming that make development easier and more scalable. But so let's dive in. I'd like to start with a quote from Linus Torvalds. He said this back in 2019, where he said, "My job really is, in the end, to say no. Somebody has to say no to this patch or that pull request. And because developers know that if they do something that I will say no to, they do a better job of writing code." Linus Torvalds has been the gatekeeper of the Linux kernel for a very, very long time, which means that a majority of what his life is reviewing code and telling people no. Personally, I don't want that to be my life. Linus later in the interview says that he's fine with it. But I want my life to be one where I can continue to create new things. I want to be enabled to create new software and get my ideas and concepts solidified. POP, plugin-oriented programming, is designed in large part to do just that. It allows for code bases to be externally augmented. Others can now extend POP projects or my code without my approval and without the arguments and debates. This means that I can focus on what I love, which is writing code and delivering features. When we come back and we look at the maintenance of open source software, a giant amount of that maintenance, a huge sum of its maintenance, is derived from reviewing code. So many pull requests come in. Pull requests, merge requests now, if you're using GitLab. and it can consume developers' lives reviewing all of this code. One of the main components and features of Salt is that it allows for collaboration without requiring communication. The code base can be completely and externally at its very core and in its very depth modified. And the original maintainer doesn't have to do anything about it. They don't have to be aware. And then one of the other things that happens with pull requests is that someone will create a feature or a concept and they'll push it into another code base. That feature or concept may be merged or approved without that needing to be vetted or used. When we go back and we look at the Unix philosophy and the way that Linux is built, Linux operating systems, it's all about lots of small pieces of code that have to prove themselves in the wild. They have to gain adoption in and of themselves. They have to be valid pieces of code that are actively operating before they become widely used and merged into the mainstream of a larger application base or an operating system. POP allows that to work on a code-based level so that external components to a piece of software can be built, developed, used, and expanded upon independently, and only when they're mature do they get merged into a mainline piece of code or a mainline distribution of an application. This model enforces good code and development practices through usage and through real-world testing, not mandating that someone named Linus Torvalds says no, but rather based on their own merit and based on their own ability to grow and develop. Now, I've got this who am I slide in here because occasionally I give presentations where my entire audience doesn't know who I am. In this case, my entire audience knows who I am. Hi, Tom.
You're assuming the entire audience. You don't know who's watching this later.
That's a good point.
Who are you, Tom?
My name is Thomas Hatch. I am the creator of the Salt automation platform. Formerly worked in the US intelligence community. I've worked for a number of startups. Currently, I'm working as a senior staff engineer here at VMware. I've done a lot of work with large, complex systems. And in doing so, I feel that my experience makes me a candidate to propose something as bold as a new programming paradigm. So let me do a brief history of programming paradigms, but from a little different perspective. When we learn about programming paradigms, we're generally told, oh, object-oriented programming is everything, and everything works in object-oriented programming, and there's a few others that you might want to look at, and then the discussion ends. Programming paradigms developed early on with software development as we go back into before the development of the modern computer. Programming paradigms are very much so derived from mathematics. And this is where functional programming comes from. And so we can easily say that the earliest programming paradigm is that used before computers, functional programming. And then as computers became more portable and more manageable in the 60s, where they were still filling a room, but humans began to get a little more access to computers. Programming paradigms and languages started to become a thing. Procedural programming, which was really a very strong expression of Turing logic, started to come through. In the late 60s, well, in the mid 60s, a group of companies got together and said, let's make an operating system that we can all use. And they called it Multics, for a multi-user operating system. Multics, as is the case with, I would argue, many multi-corporate collaborations didn't really fly. Instead, a few folks who had been working on Multics in 1969, a lot happened in that year, great year. A few folks working on Multics in 1969 said, we've learned a lot about operating systems. I bet we could just cook one up real quick. And so they made Unix. The Unix operating system was really pushed and written completely with this procedural programming paradigm. And they made a programming language to express the paradigm and so they could make that operating system. And that was C. The procedural programming paradigm worked really well and still works really well today. It's very generic and simple, but it worked exceptionally well at the tasks at hand. It was very good at creating small purpose-built applications. And this led us to the Unix philosophy. In the 70s, a number of new programming paradigms were developed. Functional became more mature. Object-oriented programming became a thing. And logical programming also became introduced. But the Unix philosophy is one that became a backbone of software development. The ideas behind the Unix philosophy were that if you write software applications that are small and simple, then they can be maintained. They can be handed off to other people. And in doing so, they can also work well with each other. The idea was that back then, all software ran on a command line and everything was just streams of text. And so you'd be streaming text in and out of these little applications and you could pipe them and glue them together. Because again, there was just one interface between applications. But then in the late 80s and the 90s, there was the rise of the GUI. The graphical user interface glommed onto a programming paradigm that had been started many years earlier, but suddenly had a really clear, applicable home. And that's where object-oriented programming became so much more popular, because objects are really easy to use when we express graphical layout. And so object-oriented programming was popular and grew in popularity in large part, again, because of graphical development. But when we fast forward past the 90s and Windows, and when every application was a desktop application using a widget toolkit, to today programming has changed dramatically. Because now we build large back-end applications that are accessed through JavaScript-powered front ends. Those JavaScript-powered front ends still use object-oriented concepts, but JavaScript is nowhere near as aggressively object-oriented as languages that grew in popularity in the 90s, like Java and C++. JavaScript uses prototype object-oriented programming. It is much more still procedural and functional in nature. But those backends are getting big. And we're dealing with many multi-million lines of code projects that are monolithic and extremely difficult to maintain and use. And oftentimes when we run into a large piece of software, we say it's easier to replace the entire stack than even deal with some of this code that's aging in nature. And so this issues forth new challenges that we're dealing with today. Object-oriented programming not only grew because of graphical programming, but it also grew out of constructs and concepts that existed back in C. All object-oriented programming is, at its core, is the fact that you can have a structure with data and have functions attached to that structure. From that, we've derived many other concepts that make object-oriented programming what it is. But object-oriented programming is still a bottom-up paradigm. It is still a paradigm that was derived from abstracting the underlying system and just trying to make Turing logic work. It's not a top-down paradigm. It's not a paradigm that says, these are the large-scale development issues of the day. No, we've got a struct in C, and we can associate functions with it. And we have an object. Open source software and proprietary software are both struggling with scale issues. Today, for instance, security issues run rampant for almost every open source project. Frankly, if you're using a large open source project that doesn't have regular CVE publications, it's probably much more vulnerable and much less secure because people aren't looking as aggressively as they should. Those scale issues that we're dealing with today aren't just because of security problems, but again, because of the size and scope of the software. And then that pull request, like I was saying before, that's coming into open source projects has a dark side. It means that the human collaboration that needs to exist for the development of software is getting heavier, much, much, much heavier. And it's disabling people from being able to write more software. We have to communicate with other people so much to the point where, in many cases, it doesn't feel collaborative anymore. And you just end up, frankly, being angry while you can't just solve problems. And so all of this heavy communication means that as a software project grows, it becomes exponentially more difficult to maintain and develop. Microsoft put a publication out back in 2019 where they said, we've discovered that the larger a code base gets, the more exponentially difficult it is to maintain. I was really surprised by this publication, primarily because Microsoft had ordered a formal study on the subject, as if they didn't already know. The book called The Mythical Man Month outlined this very nicely back in the 70s, that you can't just hire more software developers and have a linear increase in software output. But my goal with POP and the plugin-oriented programming paradigm is that we can get closer to linear output relative to the number of developers that are available and working on software. Because if humans are working on smaller compartmentalized components, they can run, they can work. They don't have to deal with the same constraints that you have to deal with on a large project. And they can prototype more quickly. They can take prototypes and integrate them into other pieces of software more quickly and very easily see just what's going to happen instead of having to shove into large code bases. Also, the testing problem is real. Testing large-scale software applications is incredibly costly, incredibly heavy, and ridiculously difficult to maintain. Those tests slow down software output dramatically. Years ago, when we began introducing DevOps and CI/CD concepts, it was so exciting. You would write code and you would push it, and a few minutes later it had been tested, and you knew that it was valid before you merged your software. But now we've taken advantage of these automated testing suites, and the tests have become incredibly onerous. Most companies that I've talked to and consulted with come back and say that their test suites for their major applications take hours and sometimes days to run. That damages our ability to make compartmentalized code and to have rapid releases. And that damage pushes all the way back up into the business and prevents the business from being as agile as it needs to be, because agility is ridiculously important today. Finally, the last thing I want to mention is that we look at open source software and say freedom. But I'm going to say something that might be a little controversial. Open source software can be one of the most onerous prisons I've ever seen for the open source software developer. And that prison is derived largely from people harassing those open source developers to merge their code and to merge their ideas. Freedom is not found in a license. Freedom is found in your ability to do what you want to do and be the most productive person that you can be. My goal with POP is to make the burden on an open source developer lighter. And when I say that open source development can be a prison for the developer, I'm not alone in saying this. I've got quite a few friends who have disappeared because of the stresses of open source development. It's fairly common that an open source developer will simply abandon their project when it becomes more popular because they can't handle the stress of a large community of people constantly pushing to get code in, even when people are very well-meaning and very kind about it. I've got good friends who and know quite a few open source leaders who have developed amazing software, who frankly had nervous breakdowns because of the pressure, sold everything and moved to South America. I've actually got multiple examples of this. And so freedom is more complicated than just giving away code and letting people see and work on it. Freedom has to be about us scaling the individual and making it so that they can still have a life and produce beautiful things. And so again, this is where plugin-oriented programming comes in. What in the lava? This is why I almost always download a presentation as a PDF before I start the presentation.
Almost always.
Yeah, seems I forgot today.
Yeah, but I tell you all the time that my favorite presentations are the ones where something goes wrong. So I was about to be disappointed. So I appreciate this.
Yeah, I mean, this is a non-trivial problem we got going on here.
Can pull it up. I was looking at when you had that picture of that salt picture. I hadn't seen it in a while. When you guys did that salt photo shoot, that was a good throwback.
Oh, man.
I'm curious if I'm looking at who's here and thinking if anyone here would have thoughts on your comment that open source can be a prison. I'm wondering if anyone else feels that way or would refute that from where they sit. Shane, do you feel like you're in prison?
No, I have a desk that goes up and down.
Right, I was noticing that.
Shane's been in the military. This is easy for him. That man knows what prison is.
Socialism defending freedom.
Just realized mine can go up and down too. Ooh. Okay, stop playing with my toys. So Tyler is kind of our core team pop guy. Has Tom said anything that has made you raise an eyebrow yet, Tyler? Are you still pretty in sync with Tom?
It's all in sync here.
Just trying to create some controversy, guys. Come on.
Oh.
Yeah, no, I mean, one of the things that's great about the fact that this happened is that I have been able to download my presentation, but I'm having trouble getting it to, is that the button? Nope. I don't know how to turn on presentation mode in LibreOffice. I haven't used it for too long. It's all different now because I'm on Linux.
Linux is supposed to be better, Tom.
Linux is better.
No, send it to me. I got Windows up here. I could.
Quiet you.
I've heard many rumors that Windows will one day run on Linux and just be a desktop environment on top of Linux kernel.
Interesting.
Yeah, Novell tried that for a while.
Yeah, a lot of people have tried that over the years. And
But Microsoft tried it.
Did you just try F5?
yeah, it's weird. Let's see if it works and if it. Hey, what's it look like to everybody else?
We can see your slide, and then we can see all the properties to the right and the rest of the slides to the left.
Okay.
Just close your properties and
F5 didn't work.
no.
Okay.
Yeah, that's fine.
So I originally made this deck in Google presentations, and then with the VMware acquisition, it got pulled into Microsoft Office. And so I'm running on Linux right now because I'm an adult. And so I downloaded it as a PowerPoint from Microsoft Office and opened it in LibreOffice. So there might be some formatting issues. Okay.
Doesn't show.
So yeah, my goal is that we can revive the Unix philosophy with plugin-oriented programming if we think about things a little differently. So the Unix philosophy that I was mentioning before is all about saying that a program does one thing and does it well. And then the programs work together so that one program can intercommunicate with a foreign program. And the change that I'm going to make on the Unix philosophy is the third rule, because the third rule said that all of the data that comes in and out of an application is just text, which from a Unix philosophy perspective worked because the only interface that we had for computers was a shell. But this just isn't the case anymore. So I'm going to say that communication happens by writing programs that expose consistent interfaces that can be merged together. So we have to define what those consistent mergeable interfaces are as fundamental components of the paradigm. Now, before I go forward, I'm going to explain really quickly where this whole idea of plugin-oriented programming came from. I didn't wake up one morning and say, I'm going to write a programming paradigm. That's frankly not where good ideas come from for the most part anyway. I woke up one morning and said, oh my gosh, I've made a programming paradigm. I never would have intended to do that. Inside of Salt, we have a plugin system called the Salt Loader. I originally made the Salt Loader just so that it would be easy to add execution modules, which is why execution modules are in a folder just called modules. I didn't think I'd use the plugin system again. But only a few releases later of Salt, I realized that I wanted to make more aspects of the software pluggable. Until I looked at Salt and said, wow, there's 8 or 9 different plugin subsystems inside of Salt. A few years passed, Salt continues to grow. And I said, what would it look like if I made a standalone plugin system that would be more easily reusable? I'd love to be able to use this construct inside of other applications. And so I wrote a standalone plugin system that I called Pack. Then I thought, what would it look like? Could I make this in different programming languages? And so I wrote some very, very rough prototypes in Rust and Go, one in Nim and one in Julia. Even played around with one in OCaml. For those of you who don't know OCaml, don't bother. Go learn Nim. It's awesome. Or Julia. They're cool. So then I went back and I said, okay, I've learned a lot. I've changed how I think about this, having gone through kind of this exploration of multiple languages. And I thought, what would happen if I went back and I rewrote this thing from scratch in Python? And I called that Pack 2. Only then did I realize I'd written a programming paradigm. And so in writing a programming paradigm, I renamed it to POP for plugin-oriented programming, and started to throw away some of my original assumptions that were holding me back and saying, if it's a programming paradigm, I might as well just dive in full force. And so POP is not something that I made up overnight. POP is something which is derived from an already very scalable piece of software whose development scales because of its pluggability and solves a lot of the problems that were inside of Salt's plugin systems, and then introduces constructs which allows us to create more pluggable software. And so what this grew into is that pluggability started to have meaning in and of itself. A lot of software is pluggable. There's nothing new to plugins inside of software. But true plugin-oriented programming means that everything is a plugin. Every aspect of the software is pluggable, to the extent that an application itself, by sheer virtue of being a plugin-oriented program, can merge into any other arbitrary plugin-oriented programming program. And that universal mergeability is where we get real power. And so we start to define what it means to be pluggable. And so if you follow the simple rules of plugins when making POP programs, then your code just becomes pluggable. When you learn the concepts from POP, you're able to become free from many, many difficult code situations. When you make everything a plugin and you realize that everything you're doing is a plugin, you're able to also become free in the way that you write your code, because you now know that everything is replaceable. And you never write something that isn't in and of itself replaceable again. Being able to do things that way means that you never have a chunk of code that's too big or too complicated. You're able to isolate functionality and think differently about what software architecture should look like. And the final meaning of pluggability is this concept of app merging, the ability for us to take multiple applications and just natively fuse them together when they don't necessarily know anything about each other. So to make this possible, I'm going to talk a little bit about what plugin-oriented programming actually is. We start with something called subsystems, or subs for short. Plugin subsystems mean that we've got a component that has many plugins that can abstract the functionality of that component. Those many plugins, again, then exist inside of a subsystem. And we create subsystems on top of subsystems. So we'll make one pluggable subsystem that is going to enable another set of subsystems, or a bunch of lateral subsystems that make it so that each of those lateral subsystems in and of themselves are completely replaceable for their internal plugins. All of the applications and aspects of the code can be extended via plugins. But then those enable another layer of subsystems. There you go. See? Formatting issues. When we have something that's pluggable, it's easier to manage with large teams and complex code bases, because we're able to divide everything up into lots of little components and little pieces. We also get to address memory management differently, because we're able to isolate memory utilization to the structure of the plugins. Since everything is built in a hierarchy, one above another, instead of saying that we create random data in arbitrary places on the heap becomes ordered by the very nature and layout of the software, meaning that we know where all the memory usage is. We can trace it, we can find it, we can isolate it and we can fix it. Visibility is far more useful, I would argue, in tracking down bugs than trying to force yourself into an unnatural model. And then finally, we have subs, and each subsystem can follow a pattern. And of course, app merging. Pluggability then has rules. Subs have plugins. You create a subsystem, and that subsystem has plugins in it. Subs contain plugins. Plugins express the pattern defined in the sub. If plugins don't conform to the pattern, then you make a new subsystem. Plugins should always be small. Everything should be small. If the plugin cannot be explained to another engineer in a few hours, maximum, it is not pluggable. Subsystems need to be small. If a subsystem cannot be explained and transferred in complete ownership to a new engineer in a few hours, it's not pluggable. If we look at a program like Item, which is written entirely using plugin-oriented programming, every subsystem in that arrangement, I have been able to present to another developer, tell them how it works within always less than an hour. And they've been able to start working with it. And only needing to come back and ask questions occasionally. And I've been amazed at how quickly engineers have been able, when they're willing to stretch their minds a little bit and think and pop, how quickly they've been able to inherit code. It blows my mind, especially compared to how often I've tried to get other people to inherit code and how long it's usually taken. Everything inside of a plugin-oriented programming piece of software sits in a hierarchical namespace, the root of which is called the hub. The hub exists everywhere. And so all software inside of your application is accessible via a hierarchical namespace. This means that we always have order inside of our software. This also means we always know where everything is. And it also means that we can follow rules about isolating namespaces. And so that means that variables are stored on the hub relative to the sub and plugin that have write access to the variable. When you've got a hierarchy, a hierarchical object that is globally available, we get the benefits in our software of global variables, but we overcome the problems that arise from having global variables. Global variables are bad for a lot of reasons, chief of them being that you don't know who is editing and modifying those variables. Inside of POP, we can say that a variable exists somewhere on this hub's hierarchy, and anything deeper has the convention to write to that variable. And anything outside of that hierarchical path only has read access. If they wish to change that variable for their own purposes, it should always be copied into their own namespace. Also, this means that the namespaces mean that we can isolate the functionality of our code and that we can always present a public API. We can look at our code as if it is all a public API. This enforces us to make good software development decisions. Private APIs almost universally create problems down the road. When we force ourselves to make public style APIs for the majority of our components, then it enforces us to make clean, transferable, inheritable, and code that is free of version difficulties. With that said, you can still make private interfaces inside of POP, but they're isolated to their plugins, which means that by the sheer nature of the application, they cannot infect external componentry. All right, now we also have app merging. There's two types of app merging. There's vertical app merging and horizontal app merging. Horizontal app merging means we take two completely different applications and merge them together. Inside of plugin-oriented programming, there's no need for a construct known as a library, because you would always make an application. This flies in the face of conventional thinking, because we were all taught back in school that you should write all your code as libraries, and then an application just calls your libraries. But we all know that in reality, this isn't how things work. This isn't how people do things. People write monolithic applications. So why don't we just try and make a paradigm that matches human behavior? If people are going to write applications, let's make the applications function in a way that makes them mergeable like libraries. Again, this is what horizontal app merging is. Vertical app merging means that you have an application, but someone wants to modify or extend that application. They can create a vertical app merge that can modify that application, but doesn't necessarily need to be distributed with that application. What this does is it goes back to that concept I was saying earlier, that anyone can extend your application and they don't have to talk to you about it. How would it be possible for Linux operating systems to scale if every time you wanted to make some code that would run in a Linux operating system, if you had to get approval from Red Hat or Debian to do it? The scale would be impossible. But this is what we're running into with applications today, and especially with open source applications. App merging allows us to get past this problem. And then app merging, like all of these other things, has rules too. Everything needs to exist on the hub. Writing library code outside of the hub should be relegated to a separate code base. And the only reason I say relegated to a separate code base is because it's Python that this is implemented in. Optimally, I would write a language that would express this directly where you wouldn't make libraries. You initialize the code and you sequence it inside of initializers so that you have initializers inside of your application that defines your subsystem. And then that initializer is able to handle the plugins that are coming through. And then again, you always make small apps. If we can merge things together, why would you make apps that are bigger and bigger and bigger? Instead, you make large collections of apps, and then your deployment application is just that, a distribution of a collection of apps, which is how large-scale open source software development works anyway, which is why we still have Kubernetes distributions that occur, Linux distributions. But it allows us to, again, separate the roles and duties and responsibilities of the applications that we're building. But it also means that the flexibility that we get in what we create becomes nearly infinite. And it means that our code reuse gets significantly better. And so I'm going to diverge a little bit from these slides. And I'm running out of time. So I'm going to showcase a large code base. And this is maybe the largest pop code base that we have, although Tiamat is bringing up to rear potentially. This is item. Item is a idempotent configuration management system, which allows you to manage arbitrary APIs as well as, well, really anything you want, because it's pluggable, of course. Item, as you can see, is 3,500 lines of Python code. Not that big, not that big at all. And it doesn't have to get a whole lot bigger. The ways in which the item can be extended can almost universally be done as vertical app merges, external code bases, and that's how they're done. There are over 20 to 25 vertical app merge projects that hook into item right now. When we come back and we look at the code base, we can see that there's a top level directory called item right here. And that this is where everything, all the code resides. Inside of item, we have a couple of files that are used to define the application. And so when we're merging entire applications together, we have to define the startup sequence consistently across multiple applications. That way, the startup sequence of an application becomes mergeable. And so the CLI configuration for all of the command line options is right here inside of the CLI conf file. Then we've also got scripts.py that only exists to placate setup tools. And so really what matters when we come back here and take a look is that the structure of the application mimics its structure on the file system. This also makes handing code off very simple and straightforward. The structure of your code is literally the structure of the file system. Where something is located in the application is also where it is located on the file system. Meaning it should never be hard to find where code is. And so if we take a look inside of item, we see that there's a subdirectory that has plugins. But this sub or subsystem also has more plugin interfaces. And so these plugins in here simply define and use more deeply nested plugin subsystems. So there's a concept inside of SALT called a requisite. There's an old joke at SALT, it's inside of SALT, that if you want a new requisite, there's only one way to write it. You ask Tom to write it. Because it's so dang hard to figure out what's going on inside of the middle of the state system's algorithm. Since item is pluggable, item is a significantly more powerful item-potent runtime manager than the SALT state system. But since it's pluggable, the requisites, I can spell. The requisites can be added very, very simply. So let's take a look at the require requisite. That's it. All of a sudden, we're able to make a plugin for something that used to be impossibly difficult. And if I'm honest, after having written both of these code bases, the code base that allows that to happen was significantly easier to write and easier to maintain. What was hard was thinking differently. What was hard was getting out of an object-oriented mindset and being able to address software in a different way. But again, similarly, we've got all of these constructs. So there's a construct called an aggregator, which allows us to go back and aggregate information from multiple states inside of SALT. Inside of SALT, it's called mod aggregate. It's just a plugin in here so that in 6 lines of code, we have the ability to add a state modifier. The compiler process is also pluggable, and it uses a sequencing pattern. But so now we can come back and we can dissect each component of the compiler, but it also allows us to add compiler components, which is frankly beautiful. Because we can come back and see that, and this is like the gnarliest function ever at 73 lines, which reconciles the extend keyword and requisite ends as 73 lines. But it's all about being able to isolate everything as a plugin. And so again, now if we wanted to add a compiler component, you don't even need to modify this code. You can make an entirely different application, give it the same directory structure, and define that it's going to extend these subsystems, install it next to item, and item will inherit its functionality automatically. Or create a distribution of item that utilizes your code simply by adding it as a requirement to a Tiamat build. And bam, you've got your own version of item that has purpose-built extensions in it. And then as the main developer of item, I can watch the ecosystem until I say, oh, I trust these developers over here. They're doing good things. I think that that should be in my main line. I'm just going to add it to my list of requirements. And wham, that functionality is in my mainline distribution. I don't have to think, I don't have to spare another thought for it. Apart from saying, oh, wow, those guys are doing good work. I want to inherit their good work. Button, done. All right. That's what plugin-oriented programming is all about. We're running out of time. Ironically, despite the fact that it's 6 o'clock, I have another meeting I have to go to.
It's true. We
Never
all
end.
do. Yeah, Tom, this was actually incredibly fantastic. I always enjoy hearing you talk about POP and plugin-oriented programming. We have several Saltair episodes actually about that on our YouTube channel. This was a really cool, different approach that I haven't heard in a while. Like, this was an older presentation that I was really fantastic. Really appreciate everybody being here. We actually do have another virtual meetup today because it is in the Singapore time zone for the Asia Pacific Japan region. So if anybody wants to join that, it actually translates over to 9 p.m. Mountain Time today, which is 11 a.m. in Singapore. So those are historically very well attended, lots of people and really cool networking opportunity. So if anybody would like to come and listen to Tom speak about remote execution, we're going to be doing that in just a bit. Really, really appreciate you all being here. And Tom, of course, thank you again for sharing your wisdom and expertise so we could all hear that. Thank you everyone for being here. And I'm sorry we didn't have time for Q&A, but feel free to email us anytime at saltproject@vmware.com. And we can always connect, of course, in open hour, which is every Thursday at 11 a.m. Mountain Time. And that time is, that Zoom link to join that is at saltproject.io. So anytime you want to access anything about Salt Project, go to saltproject.io. Thank you everybody so much for being here, and we will catch you next time. Have a great rest of your day.
Thanks.